So we got this situation, so that the circle this and this touches each other externally. So you have to prove these two circles are touching each other externally. So hopefully we will have this kind of situation. Now compare these two things. You know that this is the center. Okay, so center C1, center C2. So can you find out the center of first circle? So for center we used to divide coefficient of x by 2. Okay, I'll go with the C1 and then multiply by minus. I'll write it here, minus of minus 4 by 2, comma, divide coefficient of y by 2 multiply by minus. So we will have what? Look at this. We will have 3 comma, sorry, we will have 2 comma minus 3. So this is the center of first circle. Now let's go with the center of second circle. So divide coefficient of x by 2, then multiply by minus. Divide coefficient of y by 2, then multiply by minus. So it is 5 comma 3. So suppose it is 2 comma minus 3 and this is 5 comma 3. So you got two centers, and if you'll observe this case, you will figure out radius 1 plus radius 2 will be equal to the distance between the centers. Correct? So can I say that radius 1 plus radius 2 is equal to distance between C1 and C2? If this case is valid, then it is proved that both circles are touching each other externally. So we have to find out radius. Okay, so I'll go with the radius 1. So what is the radius? You know it is g square plus f square minus c. So for circle 1, who is g? G is minus 2. So minus 2 square is 4. Who is f? F is 3. So 3 square is 9 minus c. C is 8. Okay, so it is root 5. Now go with radius 2. Again g square. For circle 2, who is g? Minus of 5. Minus 5 square is 25. Who is f? F is minus 3. Minus 3 square is 9 minus c. It is 14. Okay, so it is 20, root 20. So can I write it is 2 root 5? So you got radius 1 and radius 2. Now I'll go with the distance between the centers C1 and C2. You know it is root over x2 minus x1 whole square. So 5 minus 2 whole square, 3 minus minus 3 whole square. Okay, so it is root over 3. 3 square is 9. 3 6. 6 square is 36. It is root 45. You can also write this thing as 9 into 5, and 9 can be taken outside as 3 root 5. So look at this. Now clearly it is R1 plus R2 is equal to 3 root 5, which is equal to C1 C2. Hence it is proved that both circles are touching each other externally. Now we have to find point of contact. Okay, now look at this. Suppose it is C1, suppose it is C2. Now this is point of contact. Suppose this is point of contact. Now do you know radius 1? Yes, radius 1 is root 5. Do you know who is radius 2? Yes, it is 2 root 5. So don't you think their ratio will be like ratio CP, C1P by C2P will become 1:2? Just tell me, correct or wrong? Correct, because this is the radius distance, like ratio of distance now. Now you can apply section formula over there. So how we will get? You know that, like I'll drop that one again. So who is C1? C1 is 2 comma minus 3. 2 minus 3. C2 is 5 and 3. Okay, and this P, it is 1, it is 2. I'll go with P. So you know that it is 1 time 5 plus 2 time 2 by 3, comma 1 time 3 into 2 times minus 3 by 3. So it is P is 9, 9 by 3 is 3, minus 3 minus 1. So you got your point of intersection as 3 comma minus 1. I hope this idea is clear.